Hello.
Morning, Kevin. Can you hear me?
Yep,
How are you this morning?
I'm doing great. How are you?
Very well, thanks. I'm outside today, as you can probably tell.
Looks beautiful.
It is. Today's a really terrific day. Low humidity and obviously sunny. And so low humidity and obviously sunny is actually a really good topic or a really good scenario for what I wanted to talk to you about today. So at some point in this course, right about now, we've been working on vapor pressure and Boltzmann distributions of gases at various temperatures. And I was thinking about that as I was doing laundry this morning. And if you can see behind me, I did some laundry and I'm hanging it out. And this is the sort of thing that fits into the category again of things students know, but may not have thought about quite so much. So when I'm hanging out my laundry, which I'm doing on a clothesline. Do you have a clothesline at your house, Kevin?
Um, we have one in my shower head. It's like a bathtub. We have like a mini one in there, but we don't have one outside.
Yeah. Anyway, so yeah. So I always like a clothesline, and a clothesline works best if you've got a Boltzmann distribution and the vapor pressure is on your side. And I'm just going to hang out a few more uh, bits of clothing, and then we'll go inside and look at a couple of charts. But the you know, and I think all of our students know that if I've got my clothing sitting in the sunshine, or if it's sitting in the shade, or it's a cloudy day, I get a different rate at which my clothes dry. And there's different rate at which puddles evaporate. A different rate at which, if you're at the beach or you're hanging outside, that if you're in the sunshine or in the shade, you warm up and you dry off much more quickly in some places than the other. So I'm going to put that out in the sun for now, and we'll go inside, and I got some things to show you in there too. Hold on one second. So one of the things that I know, and one of the things that I think you know, and I think our students know, is that when it's warmer out, things tend to evaporate more quickly, just like on my clothesline. And so we have in this section of the course a few graphs that there's a lot of information in those graphs. And so I thought, let's have a quick conversation about those to try to understand what's going on. And so what this basically says is that we've got two lines here. One is a low temperature and one is a high temperature. And basically it's saying that as the number of molecules at any particular temperature, if the temperature is higher, this orange graph, we have more molecules with more kinetic energy. And so, and if it's at lower temperature, more of the molecules have lower kinetic energy. So you can see that the peak on the lower temperature graph is about a quarter of the way over, and the peak on the higher temperature graph is about a third of the way over. And so all that really means is something that I think you and I and our students kind of intuitively understand, is that at higher temperatures, the molecules have more kinetic energy. Where that matters today on me doing my laundry is you can see over here that we have this line, this dotted line, and that is the energy that the molecules need to go from the liquid phase, i.e. while still in my damp clothes, to being in the gas phase, where the wind will whip them away from my clothes as they're drying on the line. And so we can see that if we have a slightly higher temperature, the difference between the orange line and the blue line at this point in the graph, more of the molecules will be able to escape into the vapor phase, and my clothes will dry more quickly.
Yeah, that makes sense. You can see that because the line is higher, there should be more molecules that are evaporating with the higher temperature than
Right.
the lower one, right?
Right. And so if you can understand that, then we can look at some other graphs. Okay, so this is the exact same graph, but this is two different molecules. So here we've got water on the bottom, and we've got methanol on the top. Now, methanol, like isopropyl alcohol, if I look at this graph, I see that these molecules don't, at the same temperature, some molecules in water will escape to the vapor phase, but in methanol, more of them have escaped at those same temperatures. Methanol evaporates more quickly. Isopropyl alcohol evaporate more quickly than water does. And so if you can think about some experiences that you've had with rubbing alcohol, with methanol, or you've had with water, you can begin to look at these graphs or these Boltzmann distribution plots and begin to understand what they're showing us.